Good morning. Good morning. Today we are going to see about one of the case study on 3D printing of hydroxyapatite PCL composites for tissue engineering scaffolds. The abstract of the study was using hydroxyapatite and polycaprolactane as raw materials, nano and micro composites with 20 weight fraction of hydroxyapatite was prepared by melt, melt printing technology, and the scaffolds was prepared by self-developed melt differential FDM 3D printer. It was concluded that the 3D printed composite scaffold displayed higher cristianity, high tensile strength and bending strength, sufficient forces, and high porosity suitable for the bone tissue engineering. Generally, the scaffold used in the bone tissue engineering should provide support for the defected tissue. That is, it needs to have a certain mechanical strength. In addition, it should be the bioactivity, which provides external environment for the proliferation and differentiation of the tissue cells. Therefore, bone tissue engineering scaffold require the use of bioactive materials and also require a certain microscopic and macroscopic structure. In this research, polycaprolactane was used to fabricate the 3D printed bone scaffold due to its good biocompatibility, shape retention, and properties. However, it was limited in the clinical application because of due to insufficient bioactivity of the PCL. In order to improve the bioactivity of the PCL, hydroxyapatite was utilized. Hydroxyapatite has high bioactivity and has been used as a bone structural material. Hence, by using HAPCL composites in combination with the biocompatible two materials, according to the bone tissue engineering scaffolds. First, sample preparation. In the study, the nano HAPL composite particles with the HA mass fraction of 20% and micro HA PCL composite particles with the HA mass fraction of 20% was prepared by tin screw extruder and pelletizer. And finally, the raw materials, the both nano and micro particles were converted into the scaffolds with the help of melt differential 3D printer. The process parameters for the printer were nozzle aperture 0.4 mm, printing speed 85 mm per second, print layer height 0.3 mm, room temperature 20 degrees and 1 degree Celsius respectively. This is the prepared scaffold by the authors. The A source the micro HAPCL and second one is the nano HAPCL. The properties which are tested were mechanical performance test, optical microscope observation, SEM characterization, TEM characterization, and DSK analysis.